What I want to move on to today, though, is this idea of, okay, let's suppose I look at this, y equals e to the power of x, okay? Now, if I change it slightly, just ever so slightly, if I change it to y equals e to the power of 2x, can I differentiate this now? Some of you might be able to, but are you happy it's different to this? What I'm now saying is that my x, my time interval, is now twice as fast.
But still, it would be the same because, like, what?
There would be a factor in there now. There would be a factor in there.
I mean,
okay.
I thought it would be like, maybe I'm doing some calculation wrongly, but wouldn't be equal to e over x and multiply with e over x? So if we
think about what I said. Think about what I said. I said this is exponential growth, but what is changing? It's my time, my x. It's now happening twice as quickly, right? Which means that my rate of change will also be happening twice as quickly, okay? So in other words, my rate of change, dy by dx, will now be times by 2, okay? Now that is true, and you can think about it logically. You can just think about it from the idea of a rate of change in relation to exponential functions. But I want to come up with a way that will work with this more generally. Can you see that effectively what I have here is a function, that's e to the power of something, within another function, that's 2x. So the 2x, if you like, is hiding within e to the power of something. So I have a function buried within another function. I want to work out a way of dealing with functions of that type. Does that make sense? Okay, so here's what I'm going to do. I'm not actually going to start there. I'm going to start slightly simpler. I'm going to start with this one. I'm going to start with that one, okay? And I want to differentiate it. So I want to find dy by dx. Now just remind me, dy by dx, where we first started, would you be happy? This literally just means rate of change in y divided by the rate of change in x. The change in y divided by the change in x. Does that make sense? Yeah? So I'm literally just looking at change in y divided by change in x. That's literally just a fraction. Are you happy? Okay? So what I could do if I wanted to, is introduce a new variable. Look at this. The thing which is making this tricky is the bit inside. Are you happy? Yeah? So I have y equals something to the power 4, and it just so happens that something is another function. Yeah? So why not make a substitution? Why not say that is another function? So I'm just going to say, why not let u equal 3x plus 4, equal that function? Okay? Which then means that my original function would become what? Y equals u to the power 4. Does that make sense to everyone, what I've done there? Okay? So I've basically separated it up into its two component functions. I've said I've got a function, something to the power 4, and then buried within that I've got another function, which is 3x plus 4. It's like a function within a function. Okay? But then the question is, well, how on earth do I differentiate this? How on earth do I differentiate this?
Differentiate this according to you.
Good, good. So let's have a look. And this kind of plays on the idea which you were playing at the end of last lesson, Barbara. Are you happy? The first function is called u, and it's in terms of x. So u is a function of x. Does that make sense to everyone? Which means that if I differentiate it, I would differentiate u with respect to my variable, which in this case is x. Does that make sense to everyone?
Yes.
Yeah? Now what would du by dx would be? What would that thing differentiated be? It would just be 3. Yeah? And likewise for the bottom function, my y equals u to the power 4, it would be dy by du. And if I differentiate that, what do I get? 4u to the power 3. Perfect. Okay? Then it's just a case of putting it together. But the question is, how? Look what I have. I have a du by dx, and I have a dy by du. I want dy by dx. Now, if you're familiar with your fractions, this should work out, okay? If I take dy by du, okay, and if I multiply it by du by dx, are you happy that you get that thing back? Because effectively the du's just cancel, yeah? Just divide through by du. So du, gone, okay? And you're left with dy by dx. But that's exactly what I want, okay? So if I know dy by du, which I do, it's 4u to the power 3, And if I know du by dx, which I do, it's just 3, I should just end up multiplying those two things together, and I should end up with the derivative of my original function. You all happy with that? Okay? So, okay, what's 4 times 3? We can tidy that up. 12u cubed. But just remember, my original function was strictly in terms of x. It was y in terms of x. So I need to leave my final answer in terms of x as well. So how can I get rid of this u? Absolutely. I just replace it with what it was originally. That was my function. Yeah? So I get 12 lots of 3x plus 4 all raised to the power of 3. Make sense? Yeah? Makes sense? Okay. Let's give it a name. Let's give it a name. Well, I guess what we end up doing is multiplying chains of derivatives together. Like a chain is like one after the other, like links in a chain. Okay? So I'm just multiplying chains of derivatives together. It's a rule, so why not call it the chain rule? Okay? So the chain rule is useful when I have a function buried within another function. Okay? So function buried within another function. I can use this idea. Can I give you an example? Or can I give you an exercise to try? So let's call that number 1. Okay. Let's create some space over here. So can you try, for example, y equals 4 root x plus 7x, all raised to the power of 3. Can you have a go at differentiating that for me? Okay. Let's do this. First of all, which function is buried within the other function? So what am I going to let u equal? It's going to be that bit there, isn't it? Yeah, the cubed is the bigger function, and the function within it is the 4 root x plus 7x. Now, just because I don't know how to differentiate root x straight off, I need to rewrite it, so it's x to the power of something. So what would it be? 4x to the power of?
1 over 2.
A half, good, plus 7x. Okay, that makes sense? Which then means my original function, y, is y equals, well, that thing becomes u, so u cubed. Is that okay? Yeah, good. Right, okay, so therefore, I can find the derivative of u, so du by dx, good. So what's that going to be? So bring the power down. Half times 4 is 2. X to the power of, reduce the power by 1. Minus a half. Plus 7. Good. You okay? Now, just because I see this, I don't really like this. I want to put it back in the form that I got given it in other words, with the square roots. What would this thing be? X to the power of negative 1/2. Yeah, good. 1 over the square root of a half. Oh, sorry, 1 over the square root of x. So it becomes 2 over square root of x when I multiply them together, plus 7. Okay? Yep, good. If I differentiate this, it would be dy by du, good, which becomes 3u squared. Perfect. Now, if I want to put these together, if I want to find dy by dx, that was in my original function, how would I put these together? So it would be dy by du multiplied by du by dx. And you notice the du's just effectively cancel. Okay? So all right, dy by du, I've got that. That's the 3u squared bit. Okay? And then I've got to multiply that. I've got to multiply that by du by dx, which is that bit there. So I get 2 over root x plus 7. Happy? Good, excellent. What was u again? Good, so make sure you leave your final answer in terms of u. So you get 3 lots of, what was it? Sorry, I've lost it. 4 root x plus 7, all raised to the power of 2, times by this thing. 7x. Oh, 7x, sorry. 7x, all times by this thing. 2 over root x plus 7. Is that okay?